Good afternoon, all, and welcome to this session on data blending. My name is Bethany, and I'm a product consultant at Tableau. I've been working here for about a year and a half. And so the goal of this session today is really to help you be able to understand how to troubleshoot data blending and how to understand what's going on if you're not obtaining the results that you expected. So data blending is often it's quite easy to actually do, but sometimes it can be difficult to do right. And so this session is all about kind of tips and tricks around doing it right, I suppose. So as an agenda, first we'll talk about what's the difference between joins versus blends, and then different types of joins and how those relate to blending. Then we'll look at start with a simple case of having a single linking field between two data sources, and then look at what happens when we've got multiple linking fields, and how multiple linking fields can lead to the suppression of values in your secondary data source, and what happens when filtering across data sources. Then we'll look at the star value. So something that'll show up in dimensions from the secondary data source in certain situations, and so we'll look at kind of why that happens. Then how to resolve duplicates that sometimes occur when joining tables. And then finally we'll look at many-to-many relationships and how to filter across data sources with many-to-many relationships. So just to start out, plain and simple, the great rule of thumb is to use a join if the tables are from the same data source. So if you have two tables in a SQL Server database, for example, you're going to want to join those. Whereas blending is something to use when you have two tables or multiple tables from different data sources altogether. So maybe one's relational, one's a cube, or some situation like that. Now, just kind of general knowledge about different types of SQL joins. A left outer join is when you keep all of the data in your left table, I guess, table A in this case, and then anything from table B, anything from the right table that is in common with that. A right outer join is simply the reverse, so we keep everything in table B, the right table, and everything from table A that matches with that. An inner join just keeps rows of data that have the join key is common between both table A and table B. And then a full outer join includes all of your data from both tables. So when we're using blending, the join type is a left outer join. So we have this notion in Tableau of a primary data source. What that means is your primary data source is essentially the left table, if you will. So it's the table where we keep everything in the primary data source. And the secondary data source, we just keep stuff that is common with the primary data source. So if we were to look at just a simple example of that, I'll just show you some underlying data here. Okay, so here we're looking at appointments for patients. So we've got 7 patients, and each of those patients has an appointment to see the doctor. So that's kind of one data source, if you will. Then you might have a second data source that's kind of showing your patient history. Again, we've got 7 patients, not necessarily the same patients as the ones who have appointments, and it's just some various facts about their health. So I don't know, just 2 things to notice. Chris and Megan here exist in the patient history table, but there's no Chris and Megan here in the appointments table. So they're like those naughty patients who never go to the doctor, I guess. And then Sam and Will here exist in the appointments table, but there's no Sam and Will in the history table, so those are new patients. So how does that concept translate then into data blending and primary data source and all that. So we'll start out here. We're going to make the appointments table up top our primary data source. So we'll just look at who are all of the patients who have appointments. So there's Sarah and Will again, our two kind of runaway patients, or sorry, our two new patients rather. Okay, and then we'll look at, they've all got some various appointments here. So now it's showing the times that they're coming in. And so now the doctor who's seeing these patients might want to be able to cross-reference that with their history before going into the appointment. So now you'll see Tableau's made this link here on patient. It's our common field between the two data sources. And so let's just see who are the patients here. So it's matched up all of these patients that exist in both data sources, and now it's given us this null value for Sam and Will because Sam and Will don't have a patient history. So this is what we mean by like sort of a left join. Maybe I should put the primary on the left, I guess, and then the right data source gives null values if there's nothing in the secondary data source that corresponds to that value in the primary. Otherwise, it'll match them up. And then notice that our two patients, Chris and Megan here, don't show up anywhere in the table. And that's because they don't exist in the primary data source. So basically, if we were to go back to our diagram here, Chris and Megan are this white space here. And the other 5 are right here, the common ones. And then, the ones with null values, Sam and Will, would be this stuff here. So that's not in common between the two. All right, and so finally, I guess the whole point of doing this, I never even brought in illness, but the whole point of doing this was really to cross-reference this with the illnesses of those patients. And likewise, the illness shows up as null where the patients are null. So that's a left join. Now a right join is also possible with data blending, and you would achieve that simply by swapping which data source is your primary data source. So now instead of having the appointments data source be the primary data source, we'll make the history table the primary data source. So if we were to take that same example again, and just one thing to note is that the way you make a data source, the primary data source, is simply by picking something. So the first field that you bring into the view from that has to be from that data source. So if I now bring patient in here from patient history, it marks that as the primary data source, and it's the blue check mark here that indicates that it's the primary data source. So let's look at their illness as well. And now if we go back to the appointments table and then want to look at what is the appointment date that these ones are coming in at, we'll bring that in here. Now notice it's put this orange check mark next to appointments. Anything that's orange indicates that it's a secondary data source. And so now here we're seeing those null values again for Chris and Megan, and that is because Chris and Megan do not exist in the appointments table. And then we've got our 5, so again, Chris and Megan are, they're this stuff here. They exist in the primary, they don't exist in the secondary. The other 5 patients exist here. And then Will and Sam, they simply don't show up, and that's because they're this stuff in the secondary source, the appointments table, that don't exist in the history table. So now if we wanted to do an inner join, so an inner join is simply a filtered down version of a left or right join, because it just keeps the stuff that's common between both data sources. So if we were to go back to that same example, we can achieve an inner join just by saying exclude the null values, because these patients here, Chris and Megan, don't exist in both data sources. So excluding nulls is the way to achieve that. Now we're looking at an inner join. It's just got those 5 patients that are common between both data sources. Now the last type of join is the full outer join. This is not possible with data blending. So if you require a full outer join, the only way to get there is through sort of some ETL or using a federated database. All right, so next thing we're going to look at just a little bit at the architecture of how blending actually works, because it's fundamentally different to how joining tables works. When you join tables, it's done at the row level. So if I join some table with 1 million records to another table with 1 million records, we're going to have to map together, but all 1 million items. With blending, we aggregate each table first and then make the join, essentially. So let's say you're looking at, in one data source you've got sales, and in another one you've got cost of goods. So and let's say you want to analyze it then across months, for 12 months, let's say. So both of those tables could easily have 1 million records. But what Tableau will do is send a query to the sales database and aggregate that up to the month level, and it'll give just 12 query results to Tableau. So one sum of sales amount for each month. And it'll do the same for the cost of goods file. It'll send a query there, and it'll retrieve just 12 values into Tableau. One value of aggregate value of cost of goods for each month. And then when we do the blend in Tableau, it's just mapping the sales to cost of goods values across 12 different rows of data, one for each month. So what that means is that occasionally blending can be better for performance if you are aggregating the data at sort of a high level of detail. In that case, where we're just, instead of comparing on a million rows, we're comparing 12 rows. And so the beauty with this is that you can dynamically select to what level you want to aggregate the data based on what you're trying to analyze. So in that example, if we're comparing it across months, we aggregate to the month level. But if we want to compare across states, then we aggregate to the state level, and then we compare 50 values. So let's look at an example of this, how what happens when you change the level of aggregation of the data before or while blending. So we're going to look at this with just a very simple example. Let me clear this off. Okay, so we've got 2 tables. One is sales value, so we've got 3 customers, Joe, Jim, and Mary, and 3 products, office supplies, technology, and furniture. So these customers buy these products for some sales values. And then equally, we've got a second data source that our marketing people keep track of. Same 3 customers, Joe, Jim, and Mary, and same 3 products, furniture, technology, and office supplies. And so each of these customers is being sent a promotion voucher for these products. And then the delivery method is just indicating whether they received the promotion voucher by mail or in store. So it's possible that a customer purchased a product or received a promotion voucher for a product that they didn't buy, or they received a promotion voucher for a product that they did buy. So looking at Joe, for example, he was given promotion vouchers for furniture and technology. He used the voucher for technology, but he also purchased a product for which he did not receive a promotion voucher. Okay, so now let's say we want to analyze our sales across products, and we basically want to be able to compare across those products. Do products that have higher sales also have a higher number of promotions? So now we can come in here and notice that there is the possibility of linking on customer and product, but Tableau is pretty smart, and it's only actually made the link on product for us because that's the only dimension that we're actually comparing these across. So now let's look at how many promotion vouchers there are for each product. So 2, 2, and 1. So 5 promotion vouchers in total have been sent out. And so one of the reasons why we wouldn't want to just link on customer name is for performance then, because then rather than just aggregating the number of promotion vouchers to the product level, we have to aggregate it to the product and customer level. And that means you're making the comparison across more categories, and that's something that can take a kind of a hit to for performance. Now if we were to, instead of wanting to analyze this across products, we wanted to analyze it across customers. So now we can see now we've got our 3 customer names and total of 5 promotion vouchers still. Now if we come to our secondary data source here, you will notice that Tableau has gone and dynamically changed the link so that now it's linking on customer name since that's what we're comparing on, and it's turned off that link on product since that's no longer relevant. But what a lot of people who are kind of just learning data blending will do is they'll click the link on absolutely everything. And now watch what happened. Well, before we had 5 promotion vouchers, now it's just dropped down to 2, so we've more than cut in half the values that we're looking at. So actually making these additional links can cause you to lose information in a way. And let's look at why that is. So if we come back to this data source here, so first let's look at the example when we're just linking on customer. So what Tableau is going to do here, it's going to look at the primary data source, say, okay, Joe, Jim, and Mary. What's going on with those 3 guys in the secondary data source, in the promotions data source? Well, Joe has bought 2 promotion vouchers. There he is. And Jim has received 1 promotion voucher. And there he is. And Mary has received 2 promotion vouchers. And there she is. So, okay, simple enough. Now when we link on product, we're basically saying, show me which customers, what this is showing basically is which customers actually used the promotion vouchers that they were given to purchase an item. And so if we come back to this data source here, now we're not just looking at customer alone. We're looking at the combination of customers and products. So Joe and office supplies. That doesn't exist. Joe did not receive a promotion voucher for office supplies. What about Joe and technology? Yes, Joe and technology did receive a promotion voucher, so we'll count that. And that's the 1 promotion voucher that is being shown here. This one for Joe and furniture is not being shown because he didn't actually buy furniture. And so when we link on both customer and product, we're saying show just the promotion vouchers for the customers and products that were actually purchased. And so now the same thing for Jim. Jim bought furniture, but Jim did not receive a promotion voucher for furniture. So linking on both suppresses his values. And that's why he's got 0 promotion vouchers here. I guess you could think of it as what was actually redeemed. And then likewise Mary and furniture, there she is. So she redeemed 1 promotion voucher. That's the one here because the last thing she purchased, Mary and she purchased technology. She didn't receive a promotion voucher for that. And this one doesn't count because she didn't actually purchase it. So kind of making links on different things actually answers kind of a different question than just simply showing sales versus promotion vouchers received per customer. So this might kind of beg the question of, well, why would you even really bother to link on something that's not in the view? Because all you're going to do is take a hit to performance and suppress some of your data, essentially. And so one of the reasons you might want to do that is for the purpose of filtering. Because the way that, so when you filter on a field in the secondary data source, the join keys that you link on will influence how that filter applies back to your primary data source. And I know that's probably quite abstract, so we're going to, again, look at that with an example. So just to pick up kind of the same example as what we had before here, just kind of linking on customer. Now let's say we want to filter on the delivery method. So let's say we want to see just the promotion vouchers that were received by mail. And so this is going to filter both data sources applying this. Okay, so it's completely suppressed Jim from this. Now let's look at what has that actually done. Bearing in mind we're linking just on customer. So, okay, here's our 3 entries where the delivery method was mail. And so because we're linking on customer, the only field that we're looking at in the primary data source then is going to be customers. So Joe had something received by mail, and Mary had something received by mail. And so if we go back to our primary data source, we're going to keep these rows. Joe and his total sales values add up to 30. There it is, 30. And then we're going to keep Mary as well, and her total sales values add up to 90. And there it is, 90. So that's how the filter applies in the case of just linking on customer name. So basically what we're saying is, show me the sales data. So this is saying, show me the sales, so total sales value for customers who received some promotion voucher by mail. It doesn't necessarily mean that all of their promotion vouchers were received by mail, because, for example, Mary here received one in store, but we keep all of Mary's values. So that's the question that's being answered in this case. Now, if we link on product instead, it's suppressing even more values, because now what it's doing is saying, all right, we're looking at these 3 values of mail here. And so now it's going back to the primary and passing through the combination of customer and product. So Joe and furniture, that doesn't exist. Okay. Joe and technology, that does exist. So we'll keep this one row here, which is $20 or pounds or whatever of sales. That's what we're seeing in the view here. And then Mary and office supplies, well, that also doesn't exist in the primary data source. So Mary just gets completely filtered out. So now the business question essentially that this is answering is, we're saying, show me all of the customers who purchased a product for which they redeemed a promotion voucher that was sent to them through the mail. Right, so before it was just show me the customers who received a promotion voucher through the mail. Now we're saying show me the customers who actually purchased the product for the specific promotion voucher that was received through the mail. So different links result in different answers to sort of different questions. And that, so basically the point of this is that there is a use case for wanting to link on fields that don't exist in the view. The problem caused by that we saw earlier on is that it suppresses values from the secondary data source. And so that kind of is a bit of a bummer. And fortunately, there is a solution to that. So the solution is with domain padding. There is an assumption, however, that must be fulfilled in order for this solution to work. Because bearing in mind Tableau does not do full outer joins. So the assumption is that the complete domain of each individual join key must be contained in at least one of the data sources. So by complete domain, I mean and each individual join key. So customer is a join key. The complete domain of customer is Jim, Joe, and Mary. So all of those customers must exist in sales, basically. The complete domain of product is our other join key. So furniture, technology, and office supplies, those three items also must exist in at least one of the data sources in its entirety. So to put this in kind of a more visual format, all of the products in one of the data sources must exist in the other data source, in data source A. So if maybe this is sales and this is promotions. So any product for which we offer a promotion voucher has to have been in the sales data set. Likewise, any customer to which we offer a promotion must exist in the sales data set. So we only give promotion vouchers to customers that have bought from us, and we only give promotions for products which we are selling, essentially. What doesn't have to be true for this solution to work is that the cross product of all products and customers exists in both data sources. So those don't need to be mutually exclusive. It's possible that I offer a promotion to a customer for a product that they don't buy, for example. So individually all products exist in the sales data source. Individually all customers exist in the sales data source. But the combination of products and customers don't need to exist in their entirety in either of the data sources. Okay, so let's look at what that means in terms of actual data structure. So I've created a new data source here of sales. So our original data source of sales just had 5 rows, or sorry, there it is, sales also, just 5 rows, okay? The new data source, which I've just used custom SQL to do this, so nothing out, I didn't use any ETL tool or anything outside of Tableau, just a bit of custom SQL and the connection dialog. And what that does is it pads the domain so that the complete cross product of customers and products exists in this data source. So there's 9 rows, right? 3 customers times 3 products is 9. So we've got furniture 3 times, once for each customer. We've got office supplies each time and 1 for each customers, and then likewise technology 3 times, once for each customer. And so in some cases we have data, and in other cases we don't have data, and so we just fill in null values for all of the remaining fields in that case. And so I've done the same thing also for the promotions data set. So now again, oh sorry, not that one. So now again, instead of having just the 5 rows, we bulk this out. We've got 9 rows, and there are some null values in here where the combination of customer and product doesn't actually exist in the underlying data source. And so the important thing is we're not actually doing an outer join here, because I don't need to go to another separate data source to figure out what are the customers that don't exist in this data source. That's a whole other issue. So this is just bulking out the cross product of all dimensions. So now, if we look at our different products, and we look at sales by those products, and then go to our promotions data set to see promotion vouchers, I may want to link on customer name for the sake of the way I want a particular filter to be applied. And now watch what happens to this promotion voucher data set when I link on customer name. So absolutely nothing at all happened when I link on both dimensions. And that's because all combinations of dimensions in the secondary data source now exist in the primary, so those values don't get suppressed. So now we've got the best of both worlds. We didn't have to go do some crazy federated database or ETL. Some reasonably simple SQL. I'm fairly SQL illiterate and managed to make this work. So you could probably copy the code from here to your own data to apply this to sort of a different scenario. And now we can apply the filters and the links according to the business question that you want to answer. Okay, and then just to show you it's fully robust, again, we can swap out product for customer name here, and then again link on product, and nothing changes here. So works like magic. All right, the next bit. This is everybody's favorite. When you start seeing stars all over your worksheets. The scenario in which this happens is when you have many-to-one relationships with the join key in a secondary data source. Again, that's, I know, a super abstract concept, so let's look at what that actually means with an example. We're going to do this with fruit stands. So I've got a table here on fruit stands, and quite simply, I'm selling 5 fruits. Maybe I'll fit this so you can see them all. Okay, I'm selling 5 different fruits, and I sell them at various fruit stands. So apples I sell at 5 different fruit stands. Oranges I just sell at 2 different fruit stands. And then this is just telling me the number of fruits sold at each of those stands. So that's one table. Then we've got another table here on inventory, right? So this is now a completely separate data source. In this data source, again, I've got fruit. And I've got kind of providers, suppliers, I guess is probably a better way to say it. So suppliers of that particular fruit. So 3 farms supply apples, and just 1 farm supplies cherries. And then this is telling me the total inventory or the total supply that each of those farms has of each of those fruits. And so one thing that you may want to compare is for various fruits, what's the number of fruits sold versus the inventory for those fruits, because we want to basically make sure that we have a high enough supply of the most popular selling fruits. Okay, sorry, I just fit the view here. Okay, So simple enough. Now I may want to see what's the location that these fruits are being supplied by, the farm. And if we now drop that on color, here comes that beautiful star value that annoys so many people. Okay, so what's happening here? And then we've also got farm 1. Okay, so let's look at our data set here. If we go back to inventory, cherries are coming from farm 1 exclusively. Apples are coming from a variety of different farms, and they're supplying a variety of different fruit stands. I have no way of knowing. This data structure simply does not tell me how much of inventory from farm 1 is dedicated to fruit stand, garden markets, for example. That information does not exist. However, I can make the logical deduction that 100% cherries, 100% of the supply for cherries comes from farm 1. And so what that translates into here is that we can say cherries come from farm 1. There's no other farm that supplies cherries. As for the other ones, it's impossible for me to say how many, to count a portion of my fruit sold to various farms, because that information does not exist in this data set. And so if you see a star value, it's basically telling you that you're trying to make any logical comparison based on information that data set does not supply. So despite it being perhaps a little bit irritating, it's actually a good thing, because this star value is saving you from making sort of erroneous conclusions. Now, another thing that data blending can be useful for is in resolving duplicated data that is caused from joining tables. So let's look at an example of that. Let's suppose that that you had joined those two tables. So this data set here is joining fruit stands to inventory. For those of you who are asking why would you ever join those tables, well, basically in a lot of cases, companies don't necessarily have a dedicated IT team to setting up a proper database schema, and business users may not be kind of well versed in data architecture, and the result is that they end up sort of joining tables that aren't meant to be joined. We see this all the time with clients that we work with. So just to show kind of what I've done here, I've just joined fruit stands and inventory on the fruit key. Okay, so here we've got 990 apples in terms of inventory. And let's assume basically the point of this exercise is to compare fruit sold to inventory. Okay, so it's easy to break up the fruit sold by fruit stand. Inventory here, there's no way of allocating inventory to particular fruit stands, and so what it does is take the total inventory for apples and duplicate that 5 times for each fruit stand. For cherries, it's duplicating the inventory just twice, because we only sell cherries at 2 fruit stands. Now what happens, though, if we don't have fruit stand in the view? Well, now our inventory for apples, so while before it was 990, now it's 4,950, and that's because it's multiplied the total inventory by 5. And so this is kind of the issue that can arise sometimes from joining data sets that aren't sort of a star schema. Tableau data blending can help kind of circumvent that issue. So if we were to do this with instead a blend, so let's say we're looking at fruits and fruit stands, and we want to compare fruits sold to inventory. It's doing that same thing as the join was doing, repeating 990 5 times, so one for each fruit stand. But when we pull fruit stand out of the view, it doesn't repeat that value. It just gives 990. And this is a result of the fact that data blending is an aggregate join. We don't join on the row level, but we would rather aggregate inventory to the level of fruit and then bring that value in. So this is a great way of kind of overcoming some of those issues that you might see when joining tables at a row level. And now, finally, we can use this fact to our benefit in the situation of creating kind of a hybrid mode of joins and between joins and blends. I know that I said in the beginning that kind of the rule of thumb is to use joins if they're in the same data source, use blends if they're in different data sources. But now that we've gone through a lot more around the structure of data, hopefully you'll be able to have a better understanding of how to apply various techniques according to the data structure. And so that's what this example is about. So here we've got one table, and it quite simply just has products purchased by different customers for various amounts. And so one thing that you might want to analyze is what's the total sales across various products. So that's one data source. And then we've got a completely separate data source up here on comments. And so this is just comments made by various customers in relation to their experience shopping at that store. So one customer can purchase many products, and equally one customer can make many comments. Here we're looking at a word cloud where hooray is the most used word in relation to this particular retail chain. And so now what you may want to be able to do is basically look at both of those together, so sales by product and then the comments, and we might want to be able to click on a particular product and see all of the comments made by customers who purchased that product. And likewise, we might want to be able to click on a particular comment and see all of the products that are purchased by customers who made that comment. And so I've just added some filters in here, and it appears that they are doing nothing. And let's try the other direction. So if we click on a product, and it does absolutely nothing. The reason is because these are in completely separate data sources. So here, when I click on product C, it's passing through to this data source, product C. But this data source here, all it has is comments and customers. So it gets a filter of product C and says, hey, dude, what do you want me to do with that? And then likewise, when we click on a comment here, it's passing through amazing to the products and sales data source. And that's something that doesn't exist in the products and sales data source, so it doesn't know what to do with that. And so the result is this whole thing just kind of stands still. So one way to resolve that is with a join. So here I've created now a third data source, which quite simply just joins the comments, our sales table, to the comments table using customer as a common key. So now comments and products are associated to each other via a particular customer, since that's been added as a row level item. So we've kind of solved one problem, But we've created another problem because now you'll see that the sales values are being duplicated for every single comment that a customer makes. So here Bob has purchased $12 of product A and $14 of product B. But when we remove the comments field, now he's purchased $36 and $42 of product B. And it's because of that duplication of records that's caused by joining tables. So we've solved one problem by joining them, but created another problem. And so now, remembering how blending can resolve the duplication of data, what we can do is use this master data source, I guess, that kind of contains all of the dimensions, and blend it back with the original data sources. So what that looks like for products is, we'll start out with our products here. So all of the dimensions come from the master join table, and all of the measures come from the original data source. So now we're looking at our sales values across these products, and we're not getting the duplication of results since we're using data blended, linked only on the product key. And let's do the same thing for comments. So again, our primary data source is always this master kind of dimensional table here. And then we want to size this word cloud by the number of comments from the original data source that we've received. And let's just make it a word cloud. Okay, so now let's see what happens when we put this in a dashboard. And we'll do the same thing. We'll use these as a filter. And I'll just fit this to the sheet. Okay, and we'll use the this chart here also as a filter. Okay, so now I click on product B, and it's filtering down these comments. And let's just make sure that it's actually working correctly. All right, so product B is purchased by Bob. Oops. Okay, so it's by Bob, by Janice, and that's it. And then comments made by Bob and Janice. Here we go. So we've got 2 amazings. 1 hooray. Oh my God, don't tell me. No. No, what's it doing? Okay, so now I'm going to click on product B, and it's filtered down the comments here, and let's see how it's filtered that. Okay, so who purchased product B? Just Bob and Janice. And now what comments did Bob and Janice make? So we've got amazing in there twice, boom in there once, junk in there once. Okay, hooray is only in there once. Okay, so why is this hooray all big and showing 3 records? Well, this comes down to what we've used as a join key again. So now to just bring this totally full circle, at the moment we're only linking on comments. We just used Tableau's default. It said, hey, comments is the only field in the view. I'll only link on that. And so it's not passing through customer as a field when it's doing the filtering. So it's showing us all of the comments associated with product B, but it's showing the number of records overall for those comments. So now if we link actually back on the customer field, now it's showing, okay, amazing was produced twice by Bob and Janice who bought product B. The other ones were just said once by each of those customers. And so likewise, then when we filter on a particular comment here, so if we look at doomed, and it's going to show us all of the products associated with doomed, A, B, C, D, G. Okay, let's look at our Excel sheet here. Okay, so doomed is Janice, Joe, and that's it. And then we can see that Janice bought A and B and D. Joe bought D, C, A, and G. Nobody bought F. That's why F's been excluded. But it didn't change the actual sales values. So it's filtered out the products, but it hasn't filtered out the sales amount. So likewise, that's because in this link here, we've only linked on products and not on customers. So it's not passing through the customer value in filtering sales. So now if we make that link, it's going to show us in addition to the products, it's going to show us the sales values based on the customers who made the selected comment. So that sort of concludes this presentation on data blending. I know that it's probably a lot to digest in just a 1-hour session. I just hope that what you retain from this is kind of an understanding of how you would go about figuring out what's happening on your own data. So if you're having problems trying to work something out, just narrow it down to a subset of 10 rows. We do that all the time. We'll try something on 10 rows and then scale it to 10 million rows once we understand sort of what's happening behind the scenes. Other resources you can use is on our website. There's lots of blogs as well by various customers and Tableau fans and friends as well in the community. So thank you for watching this session. Happy blending.